Hi guys, and welcome to another video in the Energy System Analysis Python course. My name is Anas Abuzayed, and in today's video we will talk about time series analysis, how to deal with time in Python and so on. So let's start initially with importing our libraries, so pandas we know so far, and NumPy as NP. So if we want to define time, let's say we define a date of today's date, 12th of May. So we say PD to date time, and then we put it here as a string. So let's say 2024, and then May, and then 12th. So this would give us basically the output as a timestamp, 2024, May 12th, and it will always put the time as 00, so as the beginning of the day. We can do it in another way by saying something like this, or even with a dot. We can do it also beginning the other way around, so 12/5/2024. And we can do it by saying 24. So what's the actual difference between all of that is by the attributes, or let's say the arguments inside this function toDateTime. So let's say we define a equals to a certain time. Now we have a, which is defined as 2024, 12, and 05. So here, if you can see, ideally this is a month. So this is December, but we want to define it as 12th of May. So how can I check if this is true or not? We can say a.year. So this would give me the year. A.month. This will give me the month. So it's 12 December. A.day. This would give me the day. You can even say a.hour, a.minute. In this case, it's all 00, so there is no sense of doing that. We can even say a.day name. And then we have it, for example, Thursday, which is 5th of December. So how can I define it to be, or to say, or to tell Python that I want this one as the day? By doing that, we say day first. So day first, it will tell Python that this is the day. So now let's define it and see what's a. So a.month. Now we have it as May. Let's say we want to define it with a time. So we take this one here and we say, okay, 3:55 p.m. So now a.hour, which is 15, so it takes the 24-hour format, and then .minute. Of course, in this case, we did not define any seconds, so a.second is 0. Another way of doing it is, of course, by saying 12 plus 3, so instead of 15, and then we have the same, so a.hour, that's the same story. So there is other ways also of doing that instead of day first, is by defining something called format. So in the format here, you can basically define your own format. Let's keep it simple without the time. So we said 12/5/24. So here we can define a format equals. So the first one we want is the day. So day, and then dot month dot year. Then if we read that, a.month, it's the same. So let's see if we can take more of this format. So let's say we want to know which day it is. So there's a function called dir, and this dir, basically, if you put anything here, it will give you the attributes that you can use for this function. So let's run it and see. For example, for this a, which is timestamp, you can use any of those to get more information. So for example, let's say day of week. So day of week, and it's not callable in this case, so 6. Here, day of week means which day of the week this is defined. So 12th of May is a Sunday, and it's defined here as a 6. Let's say we put the same, instead of 12 to have 13. And then again, day of the day, week of the day, or day of the week, sorry, it's 0. Let's go back to our list. There is something called ISO format or ISO calendar, and let's say a.iso calendar. So here it's a function, not an attribute, so we need to add the parenthesis in order to call its output. So a.iso calendar, that says 2024, the week is 20, and the weekday is 1. So from dir, I can get all of the stuff that I need to know in this, not only the date type, but in anything. Let's say I define a list, so a equals an empty list, and then dir of a, then it would give you some of the functions or the attributes that you can use with the list. So append, pop, remove, that we already learned in the previous video. So there's other ways also of defining the timestamp. One important, or let's say famous one, is using another library. It's called datetime. So we need to import datetime. That's a library also in Python, or built on top of Python. And then we say datetime, and then we say, okay, 2024, if. So it's basically the same. The only difference here, let's define this one again, just to see the difference between them. This is, the type of it is datetime to datetime, and the type of this one is a timestamp. So in order to access it, or when you want to access it, you need to know how exactly you need to access it. Sometimes they're the same. So let's say this equals to B. So a.hour and b.hour, a.month. In this case, they are the same, but there is some differences, of course, because they don't have the same type. So now let's move to a bit more complicated case by reading the data frames that I gave for this lecture. So there is 2 files here. One is called gen.csv, so 2 CSV files, and one is called gen.pu. So GN, or generation, is an actual generation for 2 solar and onshore wind farms in Germany. And solar PU is basically the capacity profiles of those. So the first one, the unit is in megawatt hour each hour. And the second one is availability as percentage of the whole power plant. In this case, let's just write it here. So for solar, it was for a power plant that has 5,467 megawatt. And for on wind, it was for 10,017 megawatt. So let's try to read it. Let's say df equals pd dot, read CSV, and then gen.csv. So we learned already that index call would give me the first column as 0. Let's try it first without. So what is df? So now we have the index is a range from 0 to 8,760. So in this case, 59, since it starts with 0. We have time, solar, and on wind. So let's say index call equals 0. So now we have the time being read here as the index, and we have the values of solar and the values of on wind. So let's check our index. So df.index would give me the indexes. They look like strings, but let's check, let's say one of them. So df.0, that's definitely a string, but in order to double check, so here we see it as a string, but we want it to be read as a date, not as a string. So the way to do that is by saying parse dates. And here either you put the column name, so we know already the column name is time. So time, this would go to this data frame or to this CSV file, and only the column with the time name would be read as date, as a date, let's say. Or we can say simply true. So both of them work. Now, if we check it, takes a minute. Now it's defined as a timed stamp. So let's see what we can do with this data frame. One thing that we can say is df.describe. So describe gives you a description of your data frame. In this case, for example, it gives the standard deviation, the mean, the four quartiles, and the maximum, minimum, and maximum, of course. So from that, you can define also the IQR. Also, the same thing would be for the wind. You see the count, because there's no any ends in this case, because the length of this data frame is 8,760, so all the hours in the year. So since the count is 8,760, we know that there is no NaN. We can just check it. So as NA, any, then this will give us false in both cases. So let's say I want to know how much exactly the standard deviation. And let's say I'll say STD solar. How can I do that? Is by, instead of calculating it actually, we can go to df describe. So df describe itself, if you say .log std and then solar, this would give you the standard deviation for the solar. So now it's defined as a float. Same thing would go also for the on wind. Let's check the index of the max. Where exactly did the maximum value happen? So we say IDX max. And then here it would give us that the solar was, the maximum value happened in 22nd of March 2013, while for the on wind it was 12th of May 2013. So here it can be a bit confusing because you don't know which one is the day and which one is the month. So in order to check that completely fine, if we go to df.index, here we see that it's ideal year, month, day, and then hour. But if we check the first 51, or let's say the first 50 indexes, and we check it like this, so till 50, not 50. So here you will see that it should be this one here that is changing. So let's say after 23 hours, this one, now the month changes. So this means that we did not read it correctly. We did not read this time here correctly. So as we did before, we say day first equals true. This would give you, let's say, kind of assurance that yes, it is correct. Just to see if it made any change, let's say df/idx or idx max, and then we try it again after we said, okay, the day is first. Now, if we read it, you can see, for example, that now it's changed. So previously it was 5th or May, now it's December. Let's check the index to see if there's any difference. Here you will see it now. So the first 23 hours until here, it's 1st of January, and then it's 2nd of January, not 1st of February as it was before, 3rd of January, not 1st of March as it was before. So now let's say we read our data frame correctly. Now let's see what we can do with it. Previously, we wanted to access any data frame, we would say df.log, and then the index name, the column name, and so on. So here our index is time. So how can we access it? By doing the same, let's say solar here, and then say, okay, 2013, 0101, and then at hour 0. So we can access it like this, or by saying, okay, df.log, we put, instead of a string here, pd.toDateTime, and then put the same string here. So either as a string, we can access it, or as a timestamp. So this way or the other, it will give us the same. Let's say not 00, let's say at 10 in the morning, just to see. So it's 519 megawatts. So that's how we can access it. For example, let's say we want the values of solar at a certain month. So a very convenient way of doing it is by saying, okay, df.log, and then at 05, or let's say at July. So this is the whole month of July, from the 1st till the end of July. You can even do the summation of it, or the mean value of it, the maximum or the minimum, whatever you want to do. The same thing, it's a slice of the whole data frame, so it's a series, and then you can apply the same functions that you did before. There's other ways also of doing it. Let's say if you want 1 month, one would be to resample them. So how can we resample data is by saying, okay, resample, and then you put a frequency is monthly. So now it's basically a group. So if you say the groups, this would give you the exact groups, how many values for them, or you can just say the summation. So this would give you the actual months each time and how much the summation of it was. So let's see, we did it previously for July, and the summation for July was 724. So this is megawatt hour. If we say over 126, that's 0.724 terawatt hour. The same thing here. So 724. Another way would be by grouping by. So we said previously we can group by. So here in datas, it's a bit different. Let's do it step by step. So if we want the months from the index, df.index. So if we say df.index.year, we know that for a timestamp, it will give me back the exact year. The same thing here would be for the index. So if we say for a month, then it would give us also the same months. So if I say that month and then unique, this would give me the 12 months in the year. Let's say day, it would be the same thing. If we say weekday, this would give us the unique values of the weekdays. So that unique, you see that it's 7 days. So as we did before, if we say dir.df.index, then it would give us the exact functions that we can use to check for. So for example, month name. So month name, and then you say, okay, put unique, then you get from January until December. Now, if we do that as a group, let's say, or use it as a group by, so we said we want it for monthly values. So if we say df.group by, and then group it by the month. So what would happen is also a group by, let's say the summation. So you would get also the same values, so 724. So let's say if we have time series data, you can do them monthly or for daily or for weekly and so on. So let's see if we can do it for a week. Same here. This will give you the 53 weeks of that year. So from, let's say, the beginning till the end, and then you get the summation. You can also have the mean value, for example. So it's also the same. You can do it based on weekday or day name. So you would say, okay, for Fridays, or let's say for Sundays, Saturdays, you get how much exactly, or let's say the mean in this case, maybe makes a bit more sense. Then you get how much exactly each day was generating out of it. The same thing would be, so here we define a grouper, let's say, and this grouper is the day name. So it will group them using that, and then from there, make several groups. If we can do it by the hour. So if we say df.index, we can see that the hour is always defined here. So let's say 1st of January, then at hour 0 and so on until the end. So if we do the same, and then we say, okay, hour, we would get each hour how much exactly was the average in that year. So you can see, for example, for solar, it's ramping up and then it goes down to 0. It starts from 0 and ramps up, then ramps down to 0. For on wind, it's a bit more stable based on that data frame, of course. So there's another function also for the datetime indexes. It's called 2 period. So it's kind of the same as resample here. that we did before. So if we say df.index, and then we say to period. So if you do it again to m, it would give you the index and then convert it into period. So for example, here it's a month, or if we want to do it as 120 minutes, so something like this, it will group the data, or let's say convert this index into a period of whatever you put here. So for example, let's say if we want, instead of hourly data, 2 hourly or 4 hourly data, you can also do it the same. So let's say we do it for M. So in M, it will give you the exact month for each one of the year, or each time of the year. And then use this group. We have our grouper, this one. And then let's say, okay, we sum it up. So it's the same thing, 0.7, for example, let's say in case of July. Another way of doing it would be to iterate over this data frame. So it's a bit more complicated, especially that Pandas offers you much easier ways. So let's say we define a data frame called mean values, or let's say we call it df values. And then the data frame, we put zeros in there, and the indexes, we want a range from 0 to 12, so 11 months. And then we do the same for the columns. So we can say max, min, and then mean. So now what we did is creating a new data frame and then iterating over this data frame using this one here as the month. So if we say df.log 2013 and then 0, 1, so let's say the first month, and then it would give us this one. Let's say if we do it like this, so 1, it would also give you January. So now let's try to iterate, or let's try to create this one. So for I and df values dot index print I, just to define it. Now we have I. So either I do it from 0 to 11 or 1 to 12. I would do it this way, just it's a bit more convenient. Now we have I. So each time I want to access my data frame, and then let's say .log. Now we have the index, which is 2013, and then the month, so .format. So this one would give me, let's say in this case, December, and then I want it for the solar. So now we have what we want to put on the left-hand side. So that's accessing my data frame. And then we say, okay, df values, .log, I, and then let's say the mean would equal this one, .mean. So the same thing would be mean, max, and min, and max. So let's do it. And then if we say df dot, we did not put the summation. Let's do the summation. So we create our data frame, then we do the summation, df dot values, for example, for the solar in July. So this one here, it's 724 gigawatt hours over that month. Now let's try to calculate the moving average. So we know that the moving average is a statistical form that can smoothen the fluctuations in values, not only in renewable or generation values. So let's try to calculate it. So if we want to have the simple moving average, value of 2, we always need the first index, or let's say the first value and the one next to it. Then we have the average over them. So in Pandas, there is a function also called rolling. So df.rolling is basically the alternative of the simple moving average. So if we say window equals 2, and then say you want the mean value. So it would give you, so of course, the first one is NaN because you don't have anything before it. So let's say that if we do it manually with a for loop. So of course, you can do anything with a for loop, but let's see how convenient it is just using pandas. If we do this one here, it would execute perfectly. Of course, it will take much more time. Let's say you have values of 10 years, then it would definitely be much more easier to do it using the DF trolling. There's also the cumulative moving average. There's many statistical tools that you can use inside pandas. Of course, the more advanced you get, the deeper you get, the more you work on data analysis, the stronger your knowledge will get. So we talked previously that we have two data frames. One is the DF, the generation, and the other one is the GNPU, which is the availability data frame. So I'm just reading them just to analyze something called curtailment and the capacity factors. So what exactly those are. So we have DF, which is the actual generation, and we have the availability. So we know that, let's look at on-wind, for example. We know that on-wind has a capacity, or let's say a nominal capacity, a nameplate capacity of 10,017 megawatts. So this means that at peak time, this would give me the whole megawatt hours as an output. Let's say now, if we go to the availability and we look at it. So for example, if we say 1st of January, at hour 0, it has an availability of 0.994548. So what exactly does that mean? That means that out of this 10,000 megawatts, 99.45 or 99.5 in this case is available to generate. Now, if we go to 31st of December, and then we go at hour 23, how much is available? 65% is available. What does this translate to in terms of actual energy? Let's say the maximum available energy. If we say 10,000 times availability, let's choose an easy name. Let's say A equals. So times A, the clock. So we said 2013, 0, 12, 31, then at. So this one here. And we want the on-wind. So at that hour, the maximum available capacity that could be generated from this onshore wind farm is 6,521 megawatt hours. Let's check at that hour. So let's say hour equals, and then let's define this one as the hour of interest. And we have it defined, and we have hour. Now let's see df.log at that hour and on wind. So we said the 6,521 is available as the maximum available output in this wind farm. And the actual generation, the actual dispatch that was drawn from that time is 6,520. Let's choose another time. So let's say in June, and then let's say 18th of June, and let's look at 17. So in terms of wind, 1,712 megawatt hours are maximum available. And it's the same case, roughly the same case is actually dispatched. So there is a bit of differences, or let's say in this case, very small differences. So here it's 0.3 megawatt hour difference. Here it's nearly 0.1, so nearly negligible differences between what could have been at a maximum dispatched from that power plant and or from that wind farm, and what's the actual dispatch. So GEN here is the actual dispatch, and this is the maximum one. Let's look at different cases. Is there an actual difference, or is it always negligible? So if we check the first day, January, and then at hour 0, and then you say, okay, 9,962 should have been generated. However, the actual dispatch was roughly 800 less. So is there a way to check how much exactly at each hour was, say, the difference between the actual dispatch and the maximum dispatch that could be drawn or could be dispatched from that power plant? In order to do that, we need a new column that is, let's say, curtailment on wind. And that curtailment on wind would be the difference between this one here, this term here, and this term here. So the maximum one minus the actual one. So either we do a for loop over every hour, or we can simply use it in pandas by saying, okay, let's say df curtailment and then on. This here, about the hour. So A dot on wind. So this one here is the whole or maximum available power that could be drawn or dispatched minus the actual dispatch. So now if we do that for the on wind, and let's try it out. So here you will see the actual curtailment that happened due to several reasons. It could be that there is too much power already from other resources, cheaper resources, or it could be due to technical restrictions. There's grid limitations. Later on in the course, you will learn to deeply investigate why this happened. Let's do the same for the solar. And then solar, but here mind that solar is not 10,000, it's 5,000. Now, if we do df.describe, just to see what are the values. So for the curtailment of the on wind, the average curtailment per hour is 2.6 megawatt hours, where the standard deviation is 28. So the maximum is 876. That's for the on wind. For the solar, for example, we can see that the maximum is 0.66. So even solar that is cheaper than wind technologies, it also got curtailed due to several factors that we will later on discuss in this course. Let's say if we want to group it by to see which month it actually did. So the same as we did before, if we do this one and then resample over the month, we can see that the winter months somehow suffered from higher curtailment for the on-wind. So that's here in October, November, and then December. November, it's not really that high, but for January, there is relatively too much. Same thing for March. If you look at solar, you can see that in summer months, so in June, July, and August, the highest curtailment for solar happened there. Why is that? It could be that there is way too much solar in the system, way too much generation in the system, and the system simply did not need it. So all of those technical restrictions, the different reasons that why this might have happened, we will discuss later on in this course when we look at how to build a model and what are the restrictions, the different restrictions that we need to take into consideration. And then when we analyze it, why exactly did this happen? But before we go that deep, we need, of course, to be very efficient in analyzing the data either in pandas or in NumPy, because otherwise we cannot really access this data. We cannot really analyze it in a very efficient way like we do here in pandas. I hope you enjoyed this video and we see you in the next one.